Assalamu alaikum, dear students of class 10. Welcome to the e-learning class of Forward Public School with your teacher Hubru. Chapter is Acids, Bases and Salts, and the topic we are going to discuss is Bronsted-Lowry concept of acids and bases. Let's start the topic with the introduction. In 1923, the Danish chemist Johannes Nicholas Bronsted and an English chemist Thomas Martin Lowry independently expanded the Arrhenius acid and base definitions and proposed new definitions of acids and bases. Although they both worked independently, but they both arrived at the same definitions. According to them, an acid is a substance that donates hydrogen ions, that is protons, and a base is a substance that accepts hydrogen ions, that is protons. Means an acid is a proton donor, while base is a proton acceptor. To understand this more, let's see this acid-base reaction. In this reaction, two chemical species, that is hydrochloric acid and ammonia, are reacting together. In this reaction, hydrochloric acid has donated its proton and is converted into chloride ion, while ammonia has accepted that proton and is converted into NH4 plus ion. As the hydrochloric acid has donated a proton, so it is an acid, while ammonia has accepted a proton, so it is a base. Let's see another example. Here HCl is reacting with water. HCl has again donated a proton and is converted into chloride ion, while water has accepted a proton and is converted into hydronium ion. HCl is a proton donor, so it is an acid, while here water is a proton acceptor, so it is a base. Here in this example, water is reacting with another chemical species, that is ammonia. Water here in this reaction has donated a proton and is converted into hydroxide ion. After donating its proton, ammonia has the tendency to accept the proton, so it accepted a proton from the water and is converted into ammonium ion. As water has donated a proton, so it is an acid, while ammonia is a proton acceptor, so it is a base. After understanding these both examples, you will now be familiar with a new term, that is amphoteric. Amphoteric is any substance that can act both as an acid and a base. As you have seen in the previous two examples, that water is capable of acting both as an acid and a base. Bronsted-Lowry concept gave us the broader definitions of acids and bases and fills in the gaps left in the Arrhenius theory. But still there is a limitation in the Bronsted-Lowry concept, and that is some Arrhenius hydroxide bases were not Bronsted-Lowry bases. For example, sodium hydroxide. Sodium hydroxide is a base according to Arrhenius, but it is not a base according to Bronsted-Lowry because sodium hydroxide cannot accept a proton. However, when sodium hydroxide is dissolved in water, it produces hydroxide ion, and this hydroxide ion is capable of accepting a proton and can act as a Bronsted-Lowry base. You can see in this reaction that this sodium hydroxide ion has accepted a proton and is converted into water. So this hydroxide ion can act as a Bronsted-Lowry base, but sodium hydroxide itself cannot act as a Bronsted-Lowry base. Using our knowledge about Bronsted-Lowry theory, we will now understand a new term called as conjugate acid-base pairs. Acids and bases exist in pairs called as conjugate acid-base pairs. To understand this, let's focus on this reaction where acetic acid is reacting with water. Here, acetic acid has donated its proton and is converted into negatively charged species. This negatively charged species can accept a proton, and you know that a proton acceptor is called as Bronsted-Lowry base. So this species can accept a proton and can act as a base. So acetate ion, that is CH3COO- is a conjugate base of this corresponding acid. So acid and base are existing in pairs. These pairs are called as conjugate acid-base pairs. Now in this example, you can see that ammonia and water are reacting together. Here ammonia has accepted a proton from water, so it is a base as it is a proton acceptor. As a result, it is converted into ammonium ion. This ammonium ion is positively charged species. This ammonium ion can donate a proton and can act as a Bronsted-Lowry acid. So it is a conjugate acid of the corresponding base, that is ammonia. Dear students, I hope you have understood the Bronsted-Lowry concept. Bronsted-Lowry acid is a proton donor, while Bronsted-Lowry base is a proton acceptor. This is the end of our topic. See you in the next one. Till then, Allah Hafiz.